So now that we have this big linear system and we've converted it to an augmented matrix, we need to follow our row operation plan to try to get the reduced row echelon form. Now, the reduced row echelon form is farther than we need to go to find the solution, but we're going to do it anyway because it tells us a lot of important information. So the way we want to begin with finding the reduced row echelon form, I always say get a 1 in the first row, first column, and then use that 1 to zero out the rest of the column. So get a 1 in the first row, first column. Get a 1 in the first row, first column. And then use that 1 to zero out the rest of the column. So we're going to use that 1 to zero out the rest of the column. I'm going to make this position my first pivot. Right now it's a 0. I can't pivot with a 0. I need something that's not 0. And on the handout, yes, we already have a 1 there. So on the handout, I suggested interchanging row 1 and row 4 because there's a 1 right down here. So I want that in the upper left corner. First row, first column. I can also put the second row in the first row and multiply by -1 because that would give me a 1. I could take the third row and interchange with the first row and then divide by -2 because that would give me a 1 up there to pivot on. But since there's a 1 down here and that's the one that I decided to start with, that's what I'm going to do. We need some notation for that because we need notation for everything. I'm going to take row 4 and I'm going to move it to row 1. So my notation for that is on the right next to row 1, I'm going to write R4 arrow R1. So that says take R4, row 4, and move it to row 1. Interchange the 2 rows. So my first row is now going to be my last row. 1, 4, 5, -9, -7. My second row will remain unchanged, -1, -2, -1, 3, 1. My third row will remain unchanged, -2, -3, 0, 3, -1. And my fourth row is my former first row, 0, -3, -6, 4, 9. And right now we're like all calculators, please. Dude, calculators. So now I'm going to use that 1 to get zeros below. The reason that I want that 1 in the first row, first column, is that we want to be able to march across the matrix. Once we finish this column, we'll move on to the next column and the next row. Next column, next row, next column, next row. That's the echelon part of the reduced row echelon form. We're going to make these steps. So now I'm going to use this 1 in the first row, first column to zero out the rest of the column. So to cancel out this -1, I'm going to say take right next to row 2, I want to say row 1 plus row 2. I'm going to write next to the second row of the augmented matrix, R1 plus R2 to indicate that I'm replacing the second row with the sum of the first row and the second row. My first row is not changing because that's where my pivot is. 1, 4, 5, -9, -7. I'm just going to add this row to the second row. So 1 minus 1 is a 0. 4 minus 2 is 2. 5 minus 1 is 4. -9 plus 3 is -6. -7 plus 1 is -6. And so I got that 0 there. In the first column, second row is now a 0. That's what we want. I have eliminated x1 from those first 2 equations. So next up, I want to get rid of the -2. I want to turn that into a 0. So I'm going to take 2 times row 1 and add it to row 3. So off next to the third row, I'm going to write 2r1 plus r3 to say multiply the first row by positive 2 and add it to the third row. So I'm going to write in small numbers above row 1 what 2 times row 1 looks like. So that's going to be 2, 8, 10, -18, -14. So 2 minus 2 is 0. 8 minus 3 is 5. 10 plus 0 is 10. -18, and 3 is -15. -14 minus 1 is -15. And then the last row, I can leave the same. 0, -3, -6, 4, 9. Put my brackets around my augmented matrix. Circle my first pivot. That first column is now what I consider done. I got a 1 in the first row, first column, and I've used that 1 to zero out the rest of the column. Any questions? Cool. So everybody looking forward to doing this just on your calculating machine? The answer is yes, you are looking forward to this on your calculator because you don't want to do this by hand all the time. All right. So now I can have this first column. The first column is done. First column is done. I don't need quotes. Actually, yeah, because that's what I call it when I finish that first column. So since the first column is done, I move on to the second column. I go to the second column and the second row. I move over 1 column and then down 1. And I think, can I pivot here? Can I get a 1 here? And the answer is yes. So move on to the next pivot. So the next pivot is going to be the second row, second column. We decide that there's going to be there can be a pivot there because we can get a 1 there without using the first row. We don't want to use the first row and add it to anything anymore, because if I add a multiple of the first row to any of these other rows, all of a sudden it's going to mess up these zeros that we worked so hard to get. So I'm going to move on to the next column, next row, and I'm going to make that a pivot. And I can just multiply this row by a 1/2. So I'm going to replace row 2 with 1/2 row 2. So next to row 2, I'm going to write 1/2 row 2. And so that's going to give me a new row 2. Then I'm going to use that second row to zero out the rest of the column, zero out above and below. So let's switch pages. So once I multiply that second row by 1/2, my equation, my augmented matrix, the first row will be 1, 4, 5, -9, -7. My new second row will be 0, 1, 2, -3, -3. My third row, which is going to be 0, 5, 10, -15, -15. And my fourth row will be 0, -3, -6, 4, 9. That was a lot of writing for such a small thing to do, but I wanted that pivot to look like a 1. Now that I've got a 1 in the column, I'm going to use that 1 to zero out the rest of the column. So I'm going to do a bunch of stuff. I'm going to do first row. To get a 0 where this 4 is, I'll have to take -4 times row 2 and add it to row 1. So my second row, I'm going to write my second row now because it's not going to change. So I'm going to write in the second row 0, 1, 2, -3, -3. So now I'm going to take -4 times row 2 and add it to row 1. That's going to be my new row 1. So -4 times row 2 will look like 0, -4, -8, 12, and 12. So 0 and 1 is 1. -4 and 4 is 0, like we wanted. -8 and 5 is -3. 12 minus 9 is 3. 12 minus 7 is 5. So there we have the first row, second column as a 0. Pivoting here in the first row, first column, and pivot there in this second row, second column. Now I need to get rid of the 5 in the third row. So I'm going to do -5 times row 2 and add it to row 3. So I'm going to write down what -5 times, forgot the 5. So -5 row 2 plus row 3. So I write that reminder of what I'm doing next to the third row. Now I'm going to write down -5 times row 2. That's going to be 0, -5, -10, 15, and 15. And so my new row 3 is going to be 0 and 0 is 0, -5 and 5 is 0, -10 and 10 is 0, -15 and -15 is 0. Sorry, 15 and -15 is 0, and another 15 minus 15 is 0. So that third row is now all zeros. Any questions? All right. You may have seen that coming. That's the kind of thing that you want to see coming when you start looking at things. We see that once we started messing with these equations, this second row and the third row were multiples of each other. That means we have an extra equation here. When a linear system has an extra equation in it, the reduced echelon form will get this row of zeros. Say, hey, we didn't need one of them equations. All that a row of zeros means is that you had an extra equation that you didn't really need. It was not adding anything to the system. Next up, we still have to continue our march down the second column. And I got to get rid of this -3 in the second column of the fourth row. So I'm going to do 3 times row 2 plus row 4. And I'm going to write that next to row 4 to indicate what I'm doing. I'm going to write down 3 times row 2. That's going to be 0, 3, 6, -9, and -9. So my new row 4, 0 and 0 is 0. 3 minus 3 is 0, just like we wanted. 6 minus 6 is 0. And then -9 and 4 is -5. -9 and 9 is 0. And now the second column is done. Now I say that the second column is done. There's a 1, and there's zeros everywhere else. Any questions? Isn't this like the most fun thing that you've done today? Heck yes. So the reason that I'm doing this example is because the next thing that happens, we want to move on to the third column and the third row, but there's a 0 there and a 0 below it. So this is not a pivot position. I cannot pivot in the third row, third column. Cannot pivot. Cannot pivot in the third row, third column. The reason is that the third row, third column and the third row, fourth column are both zeros. There's no way I can move a non-zero number into that position without breaking the stuff that I've already done. If I move this -3 down there, all of a sudden I've broken my 0 in the first column. If I move the 2 into that position, I've broken the 0 in the second column. So I can't use the -3 or the -2. I can't move anything up into that position. So I cannot pivot there. So I can't pivot in the third row, third column without breaking the zeros that, that we've already got. Those zeros that we worked so hard to get. Without breaking those zeros, we can't pivot in the third row, third column. The question is, where will this fail? This will never fail. This is why we can assign this to machines, because it's just, this always works. So we can't pivot in the third row, third column, so we move to the third row and the fourth column. We stay on that row, we just shift it over to the next column. And we can pivot on the third row, fourth column by moving the -5 up into that position. Yeah, everything that we do is reducer echelon form and then read the reducer echelon form. That's the whole thing. So we can pivot on the third row, fourth column by moving the -5 into this position. So we can pivot on the third row, fourth column. So the next pivot is the third row, fourth column. And what we're going to do is I'm going to take -1/5 times row 4 and move it into row 3. So -1/5 row 4 to row 3. So now I'm going to read by columns. The first column is going to be 1, 0, 0, 0. The second column is 0, 1, 0, 0. The third column, -3, 2, 0, 0. That's not a pivot column. The fourth column is now going to read 3, -3, 1, 0. And the fifth column will be 5, -3, 0, 0. So we can see that there's a pivot in the first row, first column, a pivot in the second row, second column, and a pivot in the third row, fourth column. We want our pivots to be as high as possible because we're building a system, we're building a technique that we have to teach to computers. So it has to be as same as we can make it, because computers are kind of dumb and they only follow the instructions we give them. Now, we're going to do the same thing. We're going to use that 1 to get zeros up in the rest of the column. And this will be the last 2 operations that we need to do. So to get in the fourth column, to get of the first row to get a 0, I'll have to do -3 times row 3 plus row 1. So that's going to be, I'm going to write down, that's just going to be a -3 down here. So that first row is now going to look like 1, 0, -3. -3 and 3 is 0. 0 and 5 is 0. So that first row is now 1, 0, -3, 0, 5. To get a 0 in the fourth column of the second row, I'll have to do 3 times row 3 plus row 2. I'm going to write a 3 next to the 1, just because that's what I've been doing in the past. And now my second row is going to be 0 and 0 is 0, 0 and 1 is 1, 0 and 2 is 2, 3 minus 3 is 0, 0 and -3 is -3. My third row will remain unchanged at 0, 0, 0, 1, 0. And my fourth row will just be a bunch of zeros. And now we've arrived at the reduced row echelon form of the augmented matrix. If I go to the last column, there's nowhere to pivot there. So that's how we know that we're done. So now the fourth column is done. The fifth column is not a pivot column. So this is the reduced row echelon form. The RREF of the matrix. Any questions? How's everybody okay? Okay. Let me stop the recording here.